All right, the major thing we learned on Monday class of graphing, okay? Given a graph, we need to be able to write down the functions, either by sine or by cosine. So we always first find out the midline. That's the step one. How do we find the midline? We base on the maximum and the minimum, and then use these two values, summation divided by 2. That's the midline. Step 2, from the maximum to the midline, the distance is the amplitude. Okay, that's how we got the A value. That's step 2. Step 3 is we want to find out the B value here. To find the B value, we have to see each figure about how much is our period. Whole period is T. For this guy, your whole period is this. This is 2 pi. So T is 2 pi. And your T equals to 2 pi over B. So we can figure out the B is 1. That's an easy one. If we see some graph like that, they don't tell us how much is here, but we can count. We can count by how many cycles it has. 1 cycle, 2 cycle, 3 cycle, 4 cycle. So T is pi over 4. And then based on this, we will be able to find out the B value, okay? So both A, D, and B, that's the easy part. How about this part? That part, for the question here, we don't have example. The phase shift part, the way we show question 3, 4, and 5, and 6. So I already teach you 2 different ways. You can choose sine, you can choose cosine. And then after you have here, you see here, if you choose cosine, basically you are seeing here, your cosine, if you have a 0 phase shift, your graph is like this. Your graph is like this. Now your real graph starting here, that means you have a phase shift to the positive 1. That's why you have -1. If you still feel confused about this value, you can plug in. When x is 1, when x is 1, 1 minus 1 is 0. Cosine 0 is 1, okay? But for doing this correct, both of you have to know that this is 1 and cosine 90 degree equals to 0. If this thing you did the wrong way, there's no way you can get that correct. All right, so we summarize what we learned last week on Monday. Now we are going to look at how do we draw the graph. Given a function, we need to be able to draw this graph by hand. Okay, let's learn how to do this. Well, the first 2 questions are just the cofunction. I already teach you the 30 important formulas. And if you use that formulas, you can easily find the answers. So cosine 20 degree, is doing this. We already know that. Okay, so cosine 23 degree equals to sine 67 degree. Sine pi over 9 is going to equals to, we can rewrite this, okay? This guy is going to equals to cosine pi over 2 minus pi over 9. That equals to cosine 18. So this becomes to 9 pi minus 2 pi. This is cosine 7 pi over 18. Okay. Now, Julia, let's see how we draw this graph.
Sorry. Can you please explain what a cofunction is again?
Oh, hold on. Let me allow. Oh, she's still not coming yet. Okay. All right. Cofunction. remember the 30 formulas. Okay. When we learn about this part, with two angles has the relationship of complementary. If two angles are complementary, means that two angle summation is 90 degree. If two angle summation is 90 degree, then your sine of 90 degree minus alpha will equals to cosine alpha. Sine and cosine are called cofunction. Same thing, cosine and sine are called cofunction. Tangent and cotangent are called cofunction. Okay. Then this guy reciprocal, sine reciprocal. Let's use my notes over here. Sine reciprocal is cosecant. Cosine reciprocal is secant. So cosecant and secant are called cofunction. Secant and cosecant are also called cofunction. Cotangent and tangent are also called cofunction. Okay. Does this make sense to you now?
Yes.
Okay. This is important. Next year, you will learn calculus BC. When we do the calculus BC, we learn the derivative. For sine x, this guy derivative is this guy's cofunction, which is cosine x. Okay. Yeah. We want to make sure we truly understand and remember and being able to apply the formulas over here so that we can do calculus BC. Now let's come back to this question. Previously, we were given a graph, and then we want to figure out the function. Now, if you were given a function, you want to be able to draw the graph, okay? Cindy, you are late for today, okay?
Yeah, sorry, my mom didn't wake up. So.
You need to wake up by yourself, okay? It is your class. All right, make sure don't be late next time. I record so you can take a look at the videos after class. Now, we want to draw this graph. Yeah, this is the first time we draw those trigonometry function by hand, okay? I will draw this one step by step to show you how do we draw this grand graph, okay? You might notice that for Clements and Dulles, we have to draw those graph by hand very often, okay? Sometimes drawing the graph is not easy. Now let's look at here. The amplitude, that guy is amplitude. That guy is the vertical shift. And the period, the B value is 1/2. That is a B value. So B equals 1/2. T equals to 2 pi over B, which is 4 pi. This is 4 pi. So when we see here, when we have to draw this by hand here, we know something, okay? First, who is the midline? 1 is the midline, correct? 1 is midline. And who is your highest value? Look at here. Doesn't matter how much inside. Your cosine range, your sine and cosine range is always between -1 and +1, okay? Look, sine x and cosine x are both bounded between -1 and the +1. So this guy, if this guy reached to -1, then this is -2. -2 plus 1 is -1. So the lowest point is going to be over here. At the maximum, if this guy go to 1, 2 times 1 plus 1 equals to 3. So your maximum point is going to reach to over here. So that's a midline. This is the lowest line. This is a maximum line, okay? So that's those trough position, that's those peak position. This is the midline position. Now we want to see here, x minus pi over 4. That means you have a horizontal shift to the right. That means you have a horizontal shift to the right by pi over 4. So at the position of pi over 4, this guy here, Cindy, when x equals to pi over 4, can you please tell me y equals to how much?
1.
When x equals to pi over 4,
Um,
this thing equals to 1, right?
yes.
And 2 times 1 plus 1 equals?
3.
That guy equals to 3. So when this guy is here, your y should be here. Does this make sense to you?
Oh, yeah.
This guy comes to here, okay? Next one. You are not able to finish the graph by just locating this point. You have to find out those pattern, okay? Look at this. Who is your period? Cindy. 4 pi, right?
Yeah.
So that means you will repeat this pattern by 4 pi. Does that make sense?
Mm-hmm.
Okay. Now, we also know that from Monday class, we noticed that sometimes we like to use those 1/4 period, okay? From here to here, that's 1/2 of the period. From here to here is 1/4 of the period, okay? So starting from the maximum value or the peak position, past 1/4 of your period, you go to the midline position. So based on this information, we would like to find out how much is the 1/4 period. How much is a 1/4?
Pi.
Very good. That equals to pi. So that means increased by pi, the point should fall into the midline position, right?
Mm-hmm.
Okay, let's look for the position where it is pi. So here, look, this is pi over 4. Next pi over 4. So 1 bar is pi over 4. 1, 2, 3, 4. So this position is increased by 1/4 of the period, correct?
Mm-hmm.
And this position should pass the midline position, yes?
Mm-hmm.
So we are going to draw another point over here. Okay? So far, so good?
Mm-hmm.
Next, when you draw this, okay, you pass the midline. Next, if you increase another 1/4 period, you are going to reach to the minimum position, correct?
Mm-hmm.
Okay, so increase another 4 bars. Increase another 4 bars. 1, 2, 3, 4. Okay, so the graph reached to this point. Does this make sense?
Yes.
Okay. So we will connect that point. Next, let's increase another 4 bars to reach to the next midline point, okay? So 1, 2, 3, 4 over here. 1, 2, 3, 4. So the point is going to fall into that position, past the midline, okay?
Mhm.
And then we are going to draw the next part, which is increase another 1, 2, 3, 4. Increase here, and then the point is going to go back to the peak position. So far, so good.
Mhm.
Okay. Now we want to connect them by the smooth line, okay? You have the good notes, you can draw it, okay?
Mhm.
All right, that's the graph here. And we want to continue finish the other part. So we notice that as long as we increased or decreased by 4 bars in the x direction, it's going to be 1/4 of the period. So here is, from here is 1, 1, 2, from here, 1, 2, 3, 4. So my point is going to be over here. And then from there, I decrease 1, 2, 3, 4. And then I'm going to reach to this minimum point. Okay. Yeah. Is there any questions for drawing this graph? Julia, do you have any question for drawing this graph?
No.
Okay. This is the one way of drawing it. What I did is we figure out amplitude, period, midline, which is a vertical shift, and also the range. Okay, we figure out the range. Why? Because this guy are both bounded between -1 and +1. So if this go to -1, that is -1 times 2, which is -2 plus 1 go to -1. When this guy go to +1, 2 times 1 plus 1, this go to 3, +3. Okay. So we found out the range. Then we can draw a bottom line and the top line, and also draw a midline. Starting from here, this is the position where you got the peak, and pi over 4 is your phase shift. So the phase shift here equals to pi over 4 to the right. Okay, and for your school, they always ask you this question: how much is your phase shift? If you only write down this, not enough. You have to specify to the right or to the left. Okay, and then you come in with this first point position, and you always want to find out your next midline position, your 12th, and then midline. Okay, you have to at least draw those points. If you don't have these points here, don't show these points here, you won't get the complete points. Is there any other way to draw this graph? Yes, there is, but may not be as fast as this way. The other way of drawing this is doing a table, okay? Do a table. So you do this table like this. Watch out here. I first write down this column. I make x minus pi over 4, okay? I do x minus pi over 4, I write down here. I make this equals to 0. And I already calculated here, 1/4 of the cycle is pi. So first make this guy go to 0. Next, make it go to pi. Next, go to 2 pi. Increase by a quarter period, one at a time. So this is increasing to pi, 2 pi, 3 pi, 4 pi. That's it. Next, you want to put a 1/2 over here. 1/2, put it in front. So this becomes to 0, pi over 2, pi, 3 pi over 2, and 2 pi, okay? Each guy divided by 2. And then you want to do cosine of this. Cosine of this guy go to 1, 0, -1. Well, if so far now you still don't remember cosine 0 equals to 1, cosine pi equals -1, you really have to watch out, okay? You have to do those things correctly without any problem. Cosine of this go to 0. Cosine 2 pi is same as cosine 0, which is 1. After you got this column, you can plug in. You can find out all your y values. You find all your y values. So you have your table like that. But here, this is x minus pi over 4. It is not the x value. So you draw another x column. And then if you want to make this go to 0, that is pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, and 17 pi over 4, okay? Now you have all those points, okay, in pair. And then you can write down each points into the correct spots, okay? And then you come to your graph. Cindy, do you like the first way I teach you here, or do you like this table way?
First way.
You like the first way, right?
Yeah.
Okay. Now, I'm going to ask you to do this with me together, okay? Before I ask you to do it, is there any questions?
Not really.
Okay, then let's go ahead and try the next one by yourself.
Okay, so we know the amplitude is 1/2.
Okay.
And the phase shift is pi. Wait, there's like a stretch in front of the parentheses, so what does that mean?
This one?
No, the 2 over there.
That's in control here.
Oh, okay. So, oh yeah, okay. So you find the period by doing 2 pi over b, so period is pi.
That's right.
And the phase shift is shifting to the left by pi.
Next.
And the vertical shift down 1, so the midline would be -1. The range, it's usually, it's bound between -1 and 1, but it has a amplitude of 1/2, so you So the way I do it in my head is like you multiply by the amplitude and then you like take into account the vertical shift. So the range would be -3/2
Very good.
and -1/2.
Perfect. Very good. Okay.
Okay, so you graph the top and bottom line and the midline.
Sure. What's the midline?
Midline is -1.
Okay. So I'm going to draw the midline. Like that. And
the
then
bottom
the
is -3/2.
Okay, let me do this. I'm going to use this guy as -1/2, okay?
Okay.
Yeah, so that I can easily draw it. This guy is -1/2. And then that guy becomes to -1, right? And then this part is going to be -3/2, okay? All right. Now, what I do next?
Okay, since there's a phase shift, so you shift it to the left by pi.
Yes. So let's specify. Let's see how much is a quarter of the period, okay? P/4 equals to pi/4, okay? So I'm going to specify 1 bar as a pi/4, okay? So this part, okay? Sorry, the quality, the paper quality they provide is not neat enough. So we draw ourselves here, okay? Now, we're starting from this position. And because this is a sine, what should I put on my y position?
The midline.
Very good. So I'm going to make it on this position, okay? All right. What do I draw next?
Because the period is pi/4,
The period is pi. The 1/4 is pi/4.
Oh, oops. Yeah, like the 1/4 of the period is pi/4. It goes up, I think.
Yes, that's right.
So
it goes up to the maximum, right?
Yeah, go up to the maximum and then it goes back down to the midline and then down to the minimum and then the midline again.
Sure.
And then that that's one period.
Yes, that's right. So on and so forth. Okay. Very good. Then you can draw the graph. Yes. Now we have the good notes. That's why we can draw very neat. Okay. Okay. And I can do something like a copy and paste. Okay. This is not good. All right. Yeah, you can just finish drawing the graph.
I think the lasso, when you click on it, it gives you an option to not copy the highlighter.
Oh, okay. All right, you can finish drawing those cycles. Next, Julia, let's do the number 5. Go ahead, please.
Okay. So the period is 2 pi.
Very good.
The phase shift is pi over 2 to the right.
Okay.
The vertical shift is -1.
Okay. Yeah, this guy does not have those asymptotes. Let's figure out the range.
Okay. The range is -3 and 1.
Very good.
Okay.
Okay, go ahead. Let's draw it.
So is it all right if we start at pi over 2?
Yeah, let's draw the
Okay, right.
trough and the peak position and the midline, okay?
Yeah, sorry. So the midline is -1.
Okay, the midline is -1. Okay.
The max is 1.
Let me change this position. So this is the midline, -1, okay? And the maximum is
1.
1. Okay.
The minimum is -3.
Good. Next.
So I guess the first point would be pi over 2.
Very good.
And it would.
Let's figure out the 1/4 of the t, okay?
I think that'd also be pi over 2.
That's right. Very good. Okay. So you can see here. Yeah, we can make each one to be pi over 2, okay?
Mm-hmm.
Okay. So when x is at pi over 2, what's my position?
Y equals -1.
It's over here. Very good. Next.
And then at pi, y would be 1.
There.
Okay, and then at 3 pi over 2, y would be -1, and then it would be -3.
Okay. So it's going to go up, go down, go up, go down, okay?
Mm-hmm.
Yeah. So we have no problem to draw this graph. Okay, and then we can connect. All right, that's it. Okay, I think you both mastered the skill now. Let's see. All right, let's see number 6 is similar, okay? For both sine and cosine, as long as you know your amplitude, your vertical shift, your period, all those questions is easy. And this one is easy because it even does not have any phase shift, okay? Now let's take a look. Let's take a look at number 7. Look at number 7, Cindy. let's see how we work on this question. Go ahead, please.
Okay, so you know the amplitude is 5, so just put that in the front.
Sure.
5 cosine. And the period is 6 pi, so you set it equal to 2 pi over 2.
Okay, 2 pi over b. So b equals?
B, sorry. And b would be 3, I think.
Hold on.
Oh, whoops. Okay.
If b is 3, that's not equal.
Oh yeah, it was 1 over 3.
1 over 3. Thank you. What I write down next?
Phase shift, right? That so
yes.
minus pi over 2.
Look, when you include the phase shift, if you have a b not equals to 1, you have to make sure you have a parenthesis here. Otherwise, the phase shift is wrong, okay?
Oh, yeah, okay.
So x minus pi over 2. And then parenthesis. Next.
And then plus 3.
Plus 3. Shift up, okay? And that's how we do this one. Right, Julie, let's do number 8.
So y equals sine I guess x plus parentheses x plus pi. And then minus 2.
Very good. The reason is because here period is 2 pi, so b is 1. Yeah, so we don't worry about here. And they didn't say anything amplitude by default is 1. Okay. Very good. Now let's take a look at here. Oh, here we haven't finished this one yet. Cindy, let's do number 9.
Okay, so there's no amplitude, I think. So y equals sine 2 is the b value.
Yeah, because t is pi. T equals 2 pi over b, so b is 2, right? And then this is a phase shift. You make sure you have a parenthesis, and then you do x.
X minus pi over 4.
Very good. Next.
And plus 1.
All right, thank you. Now, Julia, let's do number 10.
So is that all right if I do cosine for this for number 10? Okay.
Right, sure.
So y equals 5 cosine pi over 6.
Tell me how you calculate the b value.
So half of t is 6, right?
Mm-hmm.
So then t equals 12. So 2 pi over b equals 12. So b equals pi over 6.
That's right.
Okay. And then x plus 1. And then plus 5.
That's right.
Okay.
Very good, very good. Okay, this is very nice. If I challenge you, ask you, can you express this guy using sign? Can you give it a try?
Okay. So y equals 5 sine pi over 6 x minus 2.
Look, if my graph looks like that, yes, you are right. But my graph looks like this. So you might want to think what other point you want to choose.
Minus 8?
Yes,
Oh,
you
okay.
made it. Very good. You made it.
Okay, thanks.
Does this kind of make sense now?
Yes.
And we might want to see why this guy is always equals to this guy, right? Let's give a try, okay? Let's prove this to see why this guy always equal. Yeah, because you say, I can make sure this guy is one of my answer. I can also make sure that guy is my answer because sine starting from the midline and then going up. If you choose here, the problem is sine shouldn't going down like that. Yeah, starting from here. So we want to prove that these two are equal. Now let's give a try to see why it is equal, okay? We will manipulate the formulas that we have learned in the last class. So I'm going to say cosine pi over 6 x plus 1. Yes, this equals who? This should equals to, use the cofunction. I'm going to make a sine pi over 2 minus pi over 6 times x plus 1. Yes. As long as my two angle inside plus together, the cofunction work, right? Kind of makes sense? No? Hold on. Let me draw something here, okay? This is pi over 6 times x, and this guy is pi over 6. This guy is pi over 6 times x, and then minus 8 pi over 6. 8 pi over 6. So these two guys has a difference of who? Pi over 6 minus negative 8 pi over 6 equals to 9 pi over 6, which is same as 3 pi over 2. Julia, did you notice that these two angle inside together, they have a difference of 3 pi over 2? Julia, does this make sense to you?
Yes.
Okay. So basically, we are saying cosine, if you see this guy is our alpha, okay? And this guy is our beta. And alpha minus beta, this thing is alpha. Here is alpha. Here is beta. Yeah, because this guy minus this guy, this will be canceled. Alpha minus beta has a difference of 3 pi over 2. So that means cosine alpha will be same as sine beta plus 3 pi over 2. Okay? As long as they have a difference of 3 pi over 2, remember during the cofunctions, during the 30 formulas we learned last class, as long as they have a difference of 90 degrees, okay? All 270 is going to be the same. Let's see here. We can make a new formulas. Let's see here. If you have a difference of 270 degrees, 270 degrees plus alpha, you see here. We can use the formulas here by 2 steps. We use this guy as a first step. We say this is sine 180 plus 90 plus alpha, correct? Yes. Can we do that, Julia?
Yes.
So if you have a 180 plus something, we have the formula over here, which is equal to negative of this, right? Correct? So this becomes to negative of sine 90 degrees plus alpha, correct? So far, so good? You treat this guy as a package. This is your angle. If you have this angle plus 180 degrees, that is going to be negative of sine 90 plus alpha, correct? So far, so good? And then this becomes to negative of cosine alpha. We just use this formula from here into here. If we have cosine 270 degrees plus alpha, this will equals to cosine 270 degrees. We change it to 2 steps, which is 180 plus 90 plus alpha. And then cosine 180 plus this, we are going to manipulate the formulas over here. Negative of cosine alpha. So this becomes a negative of cosine 90 plus alpha. And then cosine 90 plus alpha has this formula. So that becomes to negative of negative sine alpha. Negative of negative sine alpha. This becomes to sine alpha. Okay? So when we come back to here, okay? These two guys, even though they look so different, but as long as they have the angles difference of 270 degrees, the value is the same. If you don't believe this, you can always check, double check this with a graph calculator. So we can do here as first one is 5 times cosine pi over 6, and then times x plus 1. And then go here is plus 5, okay? So look at this. This is the same one as what we see here, right, Julia? Next one, if you want to choose 5 times sine, and then you do this pi over 6, and then you do x minus 8, and then you shift up by 5. Are they identical? Julia, are they identical?
Yes.
So does this prove that these two methods give the exactly same correct answer?
Yes.
Does this make sense to you now? Does this make sense to you now?
Yes.
Okay. Let me screen capture this picture and I'm going to attach it. Okay. Next one. Cindy, let's go ahead, draw this graph. Let's tell how much, what's the function for the next question? Go ahead.
It's a sine function. So the midline is 1.
Okay.
And the amplitude is 3.
Okay.
And a period is it 16?
What do you mean? You mean the period?
Yeah, like from
Yes, t is 16. You're right, because
okay, and
1/2 of the t is 8. Very good. That's right.
yeah. So B would be 1/8 pi. Is that right? I did that in my head. So.
That's right. Very good.
Okay.
You made it. That's correct. That's right.
And there's a phase shift right by 2.
Very good.
Okay, so you write that by so it's 3 sine pi over 8
Very good.
parentheses x minus 2
Very good.
parentheses plus 1.
That's right. Can I ask you if I want to rewrite this by cosine, what I do?
I'll keep everything the same except for the phase shift.
Right.
And it would be plus 6 for the phase shift? Or,
you draw this guy from here. Looks like that. This guy shift to the right by 6. So it is minus 6, right?
oh yeah, minus 6. Okay.
That's it. Okay. If you want to change here to be plus 6, then you can see here, when x is 6, that is 3 times cosine pi over 8 times 6 plus 6, which is 12. And then this 8 and 12 can be canceled to be 3 over 2, right? Yes. Cosine 3 pi over 2 is 0. Then that term becomes 0. 0 plus 1 is 1. That means when x is 6, your point shouldn't be here. Your point should be on this location. Correct? So you know that you have to be minus 6. So the way you put the correct number here is, if you choose sine, you redraw your graph from the 0 position and you're going up. And you see this position, your new position, your real position is at 2. You shift to the right by 2, so you have a minus 2. If I ask you to do the cosine, you redraw the graph from the maximum point, and then you're going down. And now your new position is located at x equals to 6, reach to the maximum. So you have a horizontal shift to the right by amount of 6. So you have a minus 6 here. Okay? Does that make sense?
Yes.
And who is doing that thing here? This is the co-function. Okay. The guy that can make these two equal It is because of the cofunction. The reason is because, look at this. Pi over 8 times a -2 gives you a negative pi over 4. Pi over 8 times a -6 give you a -3 pi over 4. Between these two, it has a difference of pi over 2. As long as you have two angles has a difference of pi over 2, or 3 pi over 2, you can make their value equal because sine and cosine are cofunctions. As long as you pick the correct spot for the sine and also for the cosine, these two will be identical. Okay? I suppose you both know how to use the decimals. Decimal is very powerful. We will also, for pre-calculus, we will learn those parabola, conic sections, okay? Parabola, hyperbola, and ellipse, okay? So you will, if you start to manipulate the decimal, you will do many interesting things, okay? That's the thing we will learn in pre-calculus, okay? I strongly recommend that you both start to play with decimal graph, okay? Now, next question. You haven't learned this before. Maybe you'll learn this next class, but I would like to introduce a little bit. This is the first time you see this graph. This is a crazy graph, but actually we can find out the function quickly by redraw the graph. Look at this, and they even have a vertical asymptote. This looks crazy. Let's redraw this. The graph past this point, and this is the position for the vertical asymptote. That means when x equals to 2 pi, your y value go to infinity. If you do a reciprocal of this guy, 1 over 0 go to infinity. 1 over infinity go to 0. So the reciprocal for this point is going to come here. Same thing, this point is going to fall back here. So you will connect the point here, point here, point here, point here. And you are going to redraw the graph. So the graph should look like this, okay? And who is this guy? This guy is the sine. This guy is sine. So we can easily find out the midline here is 0. You don't have a vertical shift. Who is your amplitude? 2 is your amplitude. So you have your graph. Okay, so you say the pink function equals to 2 times sine of something. And you have period of 4 pi. This is a 4 pi. T equals to 4 pi. T equals to 2 pi over b. So b is 1/2. B equals to 1/2. Do you both have any questions for find out this graph? No problem, right? Cindy, do you have problem for here?
No.
Julia, you have no question for here, right?
No.
Okay, now this is a sine. Who makes this point go to infinity? You do a reciprocal, 1 over 0 go to infinity. So this graph and this graph means 2 times 1 over sine 1 over 2x. That means cosecant. Reciprocal of sine is cosecant. Sine and cosecant are reciprocal to each other, okay? So you can figure out your y equals to this. That is a graph for the original one, okay? Does this make sense? Yeah. We will continue learning drawing the secant and cosecant in the next few class, okay? The last question here. This is a tangent graph. This is the first time we see the tangent graph. For the tangent graph, if you play with the decimals, okay, you can draw the tangent graph. Okay, this is a tangent graph. Of course, this is a periodical functions, okay? It looks like this. The thing they show here, they just show one cycle. So you can use curly brackets here to make it restricted into just one period. Tangent is from negative pi over 2 to pi over 2. That's one of the period. So by doing a curly brackets, you can restrict it into just one period. Okay, so that's it. And then they changed. The old bound is between negative pi over 2 to pi over 2. The new one becomes to negative pi over 4 to pi over 4. So the strange thing for tangent is you have the formula that tangent 180 plus x equals to tangent x. That means your period is pi, not 2 pi anymore. Sine, cosine, secant, cosecant has period of 2 pi. Tangent and cotangent has period of just a pi. Now you are going to use a new formula. You don't use 2 pi over b anymore. For tangent and cotangent, you use pi over b. Pi over b equals to pi over 2. From here to pi, here is pi over 2. So b is 2. After you have b over 2, and you want to find out your vertical shift, this position, suppose should be on here. They have a vertical shift up by 1. So you put a 1 here. Okay, you put a 1 here. All right, we are out of time. I will continue to teach you the tangent graph, secant, cotangent, and the cosecant graph in the next class, okay? Make sure, for today, make sure you both, without looking at my notes, you can redraw those graphs very well on the blank worksheet. I will look for some other worksheet to let you both practice. Make sure master the sine, cosine graph, because next class, cosecant, secant, tangent, cotangent graph will be more complicated. Yeah, you can leave now. I will upload the homework and also the videos so that you can look at it, okay? Thank you. See you next week.
Okay, thank you. Bye.
Okay, bye-bye.